Okay, so basically, rotational motion 2, number 2.6, talks about the Earth's tides sliding across Earth and essentially slowing it down over time. So part A wants us to find the angular deceleration of Earth. So I started by taking the given information and turning it into an angular velocity in radians per second. So we have one rotation per day, and then I just did some dimensional analysis to get 2 pi radians over 86,400 seconds, which is the number of seconds in a day. From there, I just took the simple kinematics equations that we have and I solved for angular acceleration. And then I just plugged in the information that we have, which was pretty simple, and then got an answer of negative 4.27 times 10 to the negative 22 radians per second squared. Now B asks us, assuming that the Earth is a uniform solid sphere, what torque do the tides exert on the Earth? So for that, I just took the simple equation that we have, which is angular acceleration equals the sum of the torques over the moment of inertia. And we know that moment of inertia for a sphere is 2/5 mr squared. I solved the original equation for torque and added in moment of inertia for a sphere, and then plugged in all the numbers that we have and got a torque of negative 4.2 times 10 to the 6 Newton meters. And the last part, part C, asks if the friction force caused by the tides were all concentrated at the equator, how large would this force be? So for this, we know that torque is force times radius, so I just turned that to be in terms of force, so force equals torque over radius, and we plug in the torque that we have from the last equation, and you can Google the radius of a sphere as you would have had to do in the previous problem, and then just solve and get a force of 6.6 times 10 to the 9th newtons. And that's basically problem 2.6. Pretty straightforward.